As some people know, I'm making a 7mm, 14mm gauge model of the Bagnall Ashanti Diesels. Now these were little diesels that were built for the Ashanti gold mines in Africa, built in I think about 1933 and 1934. Very nice little things. Not very well documented, not very well known, but charming little diesels. And there were a couple of photos published by the Industrial Railway Society, and a few more details published in a very nice book called The Bagnalls of Stafford. And I've been piecing together what information I can to come up with a drawing of the locos as built. The only drawing that exists is the Bagnall drawing as originally conceived, which is effectively this one here, but actually it was built slightly differently, as is the way, and I've worked out as best I can that this is how it actually is built, and there are a few details changed. So anyway, I thought it'd be rather fun to make one, and I thought furthermore, while I was at it, I might make two. Now I do quite a bit on CAD, computer-aided design, and I'm very lucky insofar as I have a very nice small CNC machine called a Stepcraft, and this is a little desktop machine. I'm just going to swing around and show it to you, and this lives on my bench here, and this is a Stepcraft 420. As I say, it's a desktop machine, and it's designed to be a router more than anything else, and really it's designed to cut timber, making signs and do all sorts of timberish type things, and plastics and that kind of thing. But actually, because it's a sturdy machine and it's good quality, I find it does metal, non-ferrous metal, really very well indeed. And I cut brass with it and nickel silver. It will cut aluminium, although I have no call for it to do so. But I primarily use it for brass and nickel silver, and I do an awful lot of work with it. As you can see, I have different sheets just stuck down. I use double-sided tape to stick it down, and in fact I've got different thicknesses here. So when I want a component of 10 thou, that's 10 thou, that's 15, that I think is 20 thou, but I regularly cut 2mm thick brass and even thicker. It just depends what I want to make. And I just rip up a piece of whatever and stick whatever I want down. Very convenient. So very handy machine. And I've built an enclosure which, although not completely soundproof, cuts 90% of the noise out of courtesy for my own. As I was saying before the technical hitch, the enclosure cuts out 90% of the noise, which preserves my eardrums and sanity, as well as my relations with my next door neighbour. So very well worthwhile. Cost me £100 to do, and makes life much better always round. So back to the Ashanti Diesel. That's what it is I'm making, and of course one has to make loads of drawings of all the different components. One needs to develop all the components. The bonnet needs developing. You can see different iterations. Things like the bonnet I ended up making several times. Cab sides, left hand, right hand, the roof supports there, cab ends, back sheet. It's actually tanks. This we have a fuel tank and a water tank at the back end of this thing. Incidentally, we have a 60-gallon fuel tank and a 12-gallon service tank. That round thing there is a horizontal service tank. So fuel gets pumped up to there and the engine runs off of that tank. I have another working drawing to which I draw things in and add them and make sure I can fit things. And you might see here I've got a motor, a gear motor drawn in there with a bevel gear drive to that axle, but at the back end, because I changed motors, I was using smaller motors initially, but these perform better, these larger ones, and this one has had to mount vertically to sit within the tank there, because when I had a mirror of this one, it was just starting to nudge up through the floor, which was unacceptable. Bogey pivots there, and those are held in with snap fastenings, you know, like stud fastenings. Reversing quadrant there, and this here is in section, and that is actually a gear quadrant, a funny looking thing. If we go to a photograph of, photograph, oh dear, zoom in, and this is under fair usage. These here are band brakes, and unusually they're external band brakes on discs for the epicyclic gearbox, which is in here, and this gear or this lever on this quadrant operates one or t'other of the band brakes. Very, very clever system. In fact, it was a beautifully designed locomotive. Very, very nicely designed locomotive indeed. So I should be making that sort of thing. And as you can see, I've been, my working drawings for the various components for the bits and pieces. That then translates to me. This is for a 3D print. I have a Mars 2 Pro for printing, and this is the gearbox, and you can see here the band brakes, which I showed you earlier, and those I've already printed. Now you won't be able to see that properly, but that's all there. And there is a separate cover with detail that goes on the top there, and a separate sump that goes on the bottom. So we have all that sort of thing. And it's a real joy to be able to do that sort of thing. The program I used for this is a free program called Design Spark Mechanical, and this is courtesy of RS Components, the electrical company, and you can download it from there for free. And it's not good for blobby animals and that sort of thing, figures and all the rest, but it's perfectly good for this kind of work. And and I have managed to do chimneys with flares down to the boiler and that sort of thing. It took a bit of working out how it liked to do that, but I have succeeded in doing that kind of work. So a perfectly valid 3D program for modelling purposes. And I modelled up the other things. That's the 12-gallon service tank that I still have to print off, and there's a little switch panel which goes just inside the cab. Let's have a look. Oh yes, can just see that there. That's that switch panel, and that's about 5 millimeters square in reality, so I'll be lucky if that comes out, and I'll be even luckier if I don't lose it when I do manage to print it out. So that's what we're doing with all of the design side of it. Now the reality translates to a pair of these things. Now the components are mostly chopped out on the Stepcraft CNC. I'll just close the computer down so it's not producing a glare. Bear with me. Yes, I want to save that. Thank you very, very much. Bear with me. Right. Now these are produced in nickel silver. Nickel silver is a nice metal to work. I prefer it to brass. It's easier to silver solder. It's a very pleasant material. I do notice the difference when it comes to silver soldering in particular, and it isn't very much more expensive, and I personally would get it in preference anytime. Now CNC is very, very useful, particularly when it comes to things like these brass spectacle glasses. I don't know if you can see them properly. They're around the glazing. Can we see better there? Yes, we can. Around the glazing that isn't there yet, we've got these brass profiles. They're very thin and would be very fiddly to make by hand, perfectly possible, but when you're making 8 of them, a distinctive pain in the neck. However, when you're CNCing it, you can just set the machine up and it'll do it. It'll take its time, but it'll do it, and do it nice and accurately. Moreover, the plate behind it I can recess by the same amount, so these can lay in accurately for soldering, and I don't have to fiddle with them to get them in place. So that, you know, that's a nice benefit. Now I make it sound as if the CNC makes it all easy. It doesn't. It makes some processes nice and easy, and it takes some of the legwork out, but it doesn't make the whole process of scratch building jobs like this an absolute doddle by any chalk. There is still more than enough of a fiddle to make this sort of thing hard work. We have the brake quadrant in there. That's turned up on the lathe with the square base fabricated from solid, and all this is silver soldered together so that when it's soft soldered in position, the main thing doesn't fall apart. And that's the main ethos. I silver solder what I can early on so that when I soft solder the other things on, the primary structure doesn't then fall apart with a bit of soft soldering. I've still got a lot to do with this. I've got a rail at the front. I've printed these radiators, which you can't really see, but they have plenty of detail on. I have yet to fit them properly, but those will effectively plug in the front, and then there's a rail that goes in front, and that will all need soldering in. And there is brake detail to come down in here and come across and all that underneath. And there is the gear quadrant to sit in here, which we've already talked about and seen on the photo. And then, of course, all the printed detail and the roof and all the rest. So there's a fair old whack of work to get on with. This is one of the bogies. This is a front bogie with the motor flat on, and that's the bolster that mounts under the body, and as we can see, that just snaps on and off. We've got a sphere on the motor bogie bolster there, and a corresponding recess on the top bolster, and that just pings on, and that's free to rock and all the rest, but that isn't coming off. This is going to be radio controlled, and the battery will sit in there. I'll get a 1300 milliampere hour battery in there, and I'm hoping, and I haven't had a chance to double check yet, I'm hoping the charging socket will go in the sump, and I can put the leads up through the gearbox and bring them out the front of the gearbox into the engine compartment to meet the battery, but we'll see. That's the idea with that. So there we have a couple of fine gentleman's sporting engines in 14mm gauge, 7mm scale, and we'll see how we get on. But I thought you'd be interested in the progress at any rate. Thank you for watching.